Welcome back. Let's do question 6. The sketch below shows the graphs of g of x is equal to 2 to the power x plus q and f of x is equal to log of x to base half. Graph of f and the asymptote of g intersect at b. Right, we can see the graph here. Right, write down the coordinates of a. This is a. Right, the x-intercept of f. Right, the coordinates of a will be 1, 0. May I explain how I got this? Right, we know that at the x-intercept, y is equal to 0. F of x is equal to log of x to base half. And then since a is the x-intercept, y is equal to 0, 0 is equal to log of x to base half. So half is the base. Right, to raise to this exponent, we have half to the power 0 is equal to x. Right, from base to the exponent to get the number. Right, and then half to the power 0 is 1, so x is equal to 1. Therefore the coordinates of a 1, 0. Okay, then 6.2, determine the domain of f. Right, this is f, then this is the asymptote, the vertical asymptote of f, which is x is equal to 0. And then this graph is approaching the asymptote but will never touch it, so 0 is not part of the domain. Remember, domain, we're looking at the x values. Right, so it means the graph starts here and goes to the right, but will never start at 0. So 0 is not included. So it means x is greater than 0. Okay, x is greater than 0. Or you can write it like this: x element of 0, not included, using a round bracket there, to infinity. 6.3, determine the equation of the inverse of f in the form y is equal to. These are free marks, 2 marks for free. Right, let's start with the equation of f of x. So f of x is equal to log x to base half. What do we do? This is like y is equal to log x to base half. Right, remember, interchange x and y. Interchange x and y. Where there's x, put y. Where there's y, put x. So x is equal to log of y to base half. You see that? That's 1 mark for free. And then now you make y the subject. Change from logarithmic form to exponential form. This is the base, and then this is the exponent. And then we'll give you that y there. So it's going to be half to the power x is equal to y. Right, so meaning that the inverse of f, will be equal to y is equal to half to the power x. 6.4, sketch the graph of the inverse of f. Indicate on your graph the intercepts, the x-axis, and the coordinates of one of the other point on the graph, just any other point. So what you can do, we know that inverse is going to be a reflection of f about the line y is equal to x. Draw that line, y is equal to x. That's how the graph is going to be reflected. Right, and then now this point is 1, 0. So it means the point for the inverse, we're going to have 0, 1. We're going to have 0, 1. So we can have 0, 1 here. Just know that x becomes y becomes x. So interchange this, x and y. So now we have 0, 1. And then let's find any other point. We can use this equation. A simpler one will be, let's put negative 1 where there's x. So it's going to be y is equal to 1 over 2 to the power negative 1, and then y is equal to 2. So it means we can use a point where we have x being negative 1 and y being 2. So it should be this point maybe. Right, let's say this is negative 1, 2. Right, so we have 2 points, and then we can sketch our inverse of f. Right, that's the inverse of f, like that. Okay. 6.5, determine the equation of the asymptotes of g. Right, 6.5, determine the equation of the asymptotes of g. We have g of x is equal to 2 to the power x plus q. We're told that the graph of f and g, the graph of f and the asymptote of g intersect at b. So we haven't even used this point b. So let's use that point. But this is a point on f of x. This is a point on f of x. So we have to use the equation of f of x here. Right, f of x is equal to log of x to base half. Right, and then b, the x coordinate of b is half. So where there's x, we put half here. So f of x, which is y in this case, is equal to log of half to base half. Right, and then in general, just know this. In general, log of a to base a is equal to 1, or log of b to base b is equal to 1. If you want, you can change this from exponential form to log form. You can say half to the power of y, like this, and then is equal to half, right? And then this is like half to the power of y is equal to half to the power of 1, right? Therefore, y is equal to 1. So we're getting the same thing. Therefore, the equation of the asymptotes. Let's answer the question. Say, what is the equation of the asymptote? So the equation of the asymptote is y is equal to 1. That's the equation of the asymptote. Okay. And then the last one, 6.6. Describe in words the transformation of g to the inverse of f. Let's highlight these two. We have g, we have the inverse of f. Let's check the transformation here from g to the inverse of f. Actually, g is going to be g of x is equal to 2 to the power x plus 1, because we just found what? We just found the equation of the asymptote, right? And then inverse of f is equal to 1 over 2 to the power x, just like that. So how can we move from this to this? Right, 1. So now if x is negative x here, if we have a negative x here, what will happen? Right, let's change this x to negative x. We're forming a new function altogether. Let me say y. Also forming a new function, 2 to the power negative x. Right, what is the meaning of that? This is just the same as 1 over 2x. You see that? Okay, but when we change x to negative x, what type of reflection is that? That is a reflection about the y-axis. Just remember this. Let me write here. If f of x becomes f of negative x, in this case, x has been replaced by negative x, it's a reflection about the y-axis. About the y-axis. And then if f of x becomes negative f of x, like this, it's a reflection about the x-axis. You see that? So now this one shows us that this is a reflection about the y-axis, because 2 to the power x became half to the power x, and half to the power x is just like 2 to the power negative x, isn't it? Right. And then after that, there's this plus 1. If you check for our inverse, we don't have a plus 1. It's like plus 0 actually. So what has happened? It means this graph has been shifted downwards by 1 unit. So there are two things that have happened here. One, reflection about the y-axis. Then two, the graph being shifted downwards by 1 unit. It makes sense. Let's look at the graph. Let's see if we can interpret this from the graph. This is g, right? This is g, right? Let's reflect g about the x-axis. This is the reflection of g about the y-axis, right? And then that's the first step, reflection about the y-axis. Then shifted downwards by 1 unit. Shifted downwards by 1 unit to form what? To form the inverse of f, which is the red graph. Start from g, reflect it about the y-axis, then shift it downwards. It forms the red graph. Do you see that? So we can say reflection about the y-axis and translated 1 unit downwards.